Calc section P6, complex numbers. So we're going to be dealing with the old I. A complex number is any number that can be written in the form a plus bi, where a is the real part and b is the imaginary part. A plus bi is considered standard form. So when you're adding them together, you add the real parts, you add the imaginary parts. When you're subtracting them, you subtract the real parts, subtract the imaginary parts. So don't get confused by the parentheses here. This is an adding thing. So we're going to take 2 plus 6, which is 8. Negative 3i plus 5i is 2i. And that's all you can do. When you subtract, make sure, so we're going to take 7 minus 3i. You got to make sure you run that negative sign through to both of those because you are subtracting. And then 7 minus 6 is 1. Negative 3i plus 4i is 1i. So 1 plus 1i. So make sure you don't multiply here when it's asking you to add or subtract. All right. So your kind of I cheat sheet here. I is the same thing as the square root of negative 1. So I squared is negative 1. I cubed is negative I. And I to the fourth is 1. So when you're going to multiply these, you got to go FOIL. So 3 times 4 is 12. First times first. Outer times outer would be negative 3i. Inner times inner would be positive 8i. And last times that last would be negative 2i squared. Now, when you write your final answers, you should never have an I squared in it. It just should be a plus bi. Well, I squared, if you think back to the previous slide, is negative 1. So we can change I squared to negative 1, which is just going to make that 2 positive. Okay, negative 1 times 2, negative 2 is positive 2. 12 plus 2 is 14 plus 5i. Okay? All right. So, conjugate. If a complex number is a plus bi, then the conjugate is a minus bi. So when you're finding the conjugate, you take the opposite of the imaginary term. So find the product of the complex number and its conjugate. All right, so you take negative 3 plus 4i times the conjugate would be negative 3 minus 4i. Now, when you take a number times its conjugate, it kind of works out slick for you. Negative 3 times negative 3 is 9. 4 would be negative 12i, and then outer times outer would be positive 12i, and then last times last would be negative 16i squared. The I terms are going to drop, and negative 16i squared becomes positive 16. 9 plus 16 is 25. So when you take a number times its conjugate, all of your i's should drop out if you did it correctly. All right, so when you are looking at these, let's go through a couple of examples on the assignment. Let's simplify these down. So we have, this is a subtraction. So we have root 7 plus I squared. Well, that's plus negative 1, because I, then minus 6. Well, the square root of negative 81 is 9i. So negative times a negative 9i would be plus 9i. Well, those two added together is negative 7 plus root 7 plus 9i. That's your real part. Can't really do anything more with that. This is your imaginary part. Okay, let's try another one like that. This one's a multiplier. So we're going to take, we got a FOIL. Before we do that, the square root of negative 2 would be this I times the square root of 2. Because the square root of negative 1 is I, so leave that like that. It's plus 2i times 6 plus 5i. All right, so we got a FOIL. That is 6i root 2, or 6 root 2i. Inner times inner is plus 5 root 2i squared. Inner times inner is plus 12i. And last times last is plus 10i squared. So that becomes I squared makes that negative, and this I squared makes that negative. And so we have negative 5 root 2 plus 10 plus 12i plus 6 root 2i, and you can leave the roots and all that stuff separate. This is your real term. This is your imaginary term. All right. So a couple of the homework problems for you. All right. Day 2, second part. Complex conjugate. There are a couple rules in math. You can't have i's in your denominator. So you got to multiply both the top and bottom by the conjugate. So to do that, you just multiply top and bottom by the conjugate. Okay, so when I do the top, I get 15 plus 3i. When I do the bottom, I'm going to get 25. And then remember, my i's are going to cancel because it's going to be minus 5i plus 5i. And then last times last would be minus I squared. Well, that's going to cancel. And then negative I squared becomes positive 1 because that gets multiplied by negative 1. So 25 plus 1 is 26. So your final answer is going to be 15 plus 3i over 26. All right, let's try that on another one where, okay, so I like to put these in parentheses here. We got to multiply by the conjugate of the bottom. Okay, let's do the bottom first. 3 times 3 is 9. Minus 6i plus 6i is going to cancel out our middle I terms for the conjugate, and then becomes negative 4i squared. Well, that becomes plus 4 since that's negative 1. So we have 13 on our bottom, on our denominator. All right, on the top, we're going to have to FOIL it. Nothing's going to fall out for us. So we have 6. Inner times inner is 3i. Outer times outer is 4i. Last times last is 2i squared. So that I squared becomes negative 2. 6 minus 2 is 4. 3i plus 4i is 7i. So 4 plus 7i over 13 becomes our final answer. All right, so with that conjugate, you can't have i's in the bottom, so you got to multiply both top and bottom by the conjugate. All right, we talked about the quadratic formula. We talked about this in P5 a little bit. Remember, if your discriminant is positive, there's 2 answers. If it's 0, there's 1 answer. And if it's less than negative, then there's going to be, your answer is going to be in terms of I. So when you do the quadratic formula, you can get I in your answer. So let's go through one like that. So A is 3, B is 4, C is 5. So opposite of B, plus and minus, square root of B squared minus 4 times A times C, all over 2 times A would be 6. Then I got to find my discriminant in here underneath the square root sign. 16 minus becomes negative 44. So, and I'm going to have you leave it like that. So negative 4 plus and minus the square root of negative 44 all over 6 would be your, or I'm sorry. So that's negative. So that means that we can pull an I out of that. So it becomes root 44i, or I root 44, because you can, the square root of negative 1 is I. All right, so you can get imaginary numbers when you're doing the quadratic formula. All right. Let's go through a couple of these here. 38. All right, so we're going to have to FOIL the top first. So 2 minus I plus 4i and minus 2i squared is that becomes positive. 2 plus 2 is 4 plus 3i over 5 plus 2i. Okay. Then I got to multiply both top and bottom by 5 minus 2i. So the bottom's going to be 25 because that's the conjugate. So 25. Then the outer and the inner are going to drop out. Minus 4i squared becomes plus 4. So we have 29 on the bottom. Okay. And then on the top, we got 4 times 5 is 20 plus 15i minus 8i minus 6i squared. So that becomes plus 6. So 20 plus 6 is 26. And 15i minus 8i is 7i. So 26 plus 7i over 29. So that would be how you would do 38 on your assignment. All right, 44. We got to get this set equal to 0. So we're going to subtract 5x and add 8 over here. So that's going to be x squared minus 4x plus 19 equals 0. And I believe since we are doing imaginary, this is going to be a quadratic formula. So a is 1, b is -4, c is 19. So the opposite of b is 4 plus and minus the square root of b squared minus 4 times a times c all over 2 times a is 2. So I want to find that discriminant. And it is -60. And you guys, so we've got 4 plus and minus. Well, remember, the square root of -60 would be root 60 times I, or I root 60, if you want to put that in front, is the square root of -1 all over 2. And you can leave it like that for 44. All right, that's a wrap for P6.